Welcome back. Hopefully you enjoyed your activity here. If you haven't done the activity yet, you might want to stop this and wait until you get together with a partner in class and do the activity. Um, this is what you were supposed to find. So in this rational function, if the degree of the top polynomial is less than the degree of the bottom polynomial, so that means this bottom one has a bigger exponent on the highest exponent, then the equation of the horizontal asymptote is y equals 0. And I should just be able, so the bottom is bigger than the top, the horizontal asymptote is y equals 0. Um, and the idea there is that means as x gets really, really big, because it's got a higher exponent, it dominates. It goes to infinity faster than the top. So that means the bottom goes to infinity faster than the top. It's kind of like having that then. And 1 over a really, really big number is 0. So y equals 0 is the horizontal asymptote. Here, if the degrees are equal, essentially what we think of is the x's kind of cancel out, and then we just pick off the leading coefficients of the top and bottom. So the leading coefficient of the top is a, the leading coefficient of the bottom is b, then we have y equals a over b. And in fact, that was the case in the 3-minute review example, right? The degree was both 1 on the top, and so the leading coefficients were 3 and 2, and the horizontal asymptote ended up being 1.5. Right? There's the horizontal asymptote was 1.5. And wouldn't it have been nice, because that was a long 3-minute review, and the would be much easier to just pick it off in this way. Now, what happens if the top's bigger? Well, if the top's bigger, it means it goes off to positive or negative infinity faster than the bottom, which means the overall expression goes off to positive infinity. There is no horizontal asymptote. Okay, so let's see how this helps us with our homework questions. This is essentially the same question as the 3-minute review with a different rational function. State the x and y intercepts. And I'm hoping we're just getting faster at this. I don't have to show too many calculations. When x is 0, I see I got negative 4 over 6, right? Because this is 0, this is 0, this is 0, negative 4 over 6, which is the same as negative 2/3 in lowest terms. Y-intercept happens when, or sorry, the x-intercept happens when y is 0, and do that calculation here, because that's nice to see. We haven't seen many of those. Clean that up a bit. And remember, as long as the bottom isn't 0, I can multiply, right? And then it disappears. As long as this isn't true, I can do this. And of course, we'll say that we can do this because there's vertical asymptotes in the function f at x is undefined when the bottom is 0 anyway. So we can do that, and we get the answer x equals 4. So there's the x and y intercepts. Vertical and horizontal asymptotes. Okay, well, the vertical asymptotes occur when the bottom is equal to 0. And that's a little tiny polynomial equation, in fact, a grade 9 quadratic equation, minus 3 and minus 2. So x equals 3 and x equals 2 are the vertical asymptotes. Those are the equations of the vertical asymptotes. Horizontal asymptote. Well, this is the new part today, right? Since the bottom has a degree of 2 and the top has a degree of 1, what happens? Well, I look at my little table. Bottom's bigger, right? Top smaller than the bottom. There's the horizontal asymptote, y equals 0. That's it. No calculations necessary. That's as far as we go. Dandy. So what else do we have to do? Draw a sketch of the function, state the domain and range. All right, well, no problem. Sketch of the function. I have y-intercept at 0, negative 2/3. There's a point there. 4, 0. Vertical asymptotes at 3. I'm going to move over my y-intercept. Oops. Just because I didn't realize that I had to squish 2 vertical asymptotes in there. Let me do that. At 4. Okay, and then vertical asymptotes here at 2 and 3, and my scale's not very good. I don't really care too much. So this is x equals 2 and x equals 3 are the vertical asymptotes. The horizontal asymptote is y equals 0, which is pretty strange. This is surprising. It said, well, I thought the graph wasn't allowed to touch asymptotes. It's not allowed to touch vertical asymptotes. Horizontal asymptotes are, remember, long-term behavior. Way off on the left and way off on the right are the long-term behavior, the horizontal asymptotes. So that is a little bit surprising, but still true. So what happens here? Like, what does the graph look like? I don't know. Well, we need a couple more tools to figure out what happens on the graph. So for instance, I could investigate the behavior near the vertical asymptotes. For instance, x goes to 2 from the left. Well, what did we do? How do we do this? I'm going to use my logic technique. You could do a table of values. X is 1.9, 1.99, 1.999, figure out whether it's going high or low, but I am going to think of the graph. And notice I'm going to use the factored form here, because then I can think of positives and negatives, right? So my factored form is x minus 3 and x minus 2, and x is a little bit lower than 2. So what do I got then? When x is a little bit lower than 2, well, this is a negative on the top. Lower than 2 means this is a negative. And this isn't where I get the teeny negative from, right? This is actually just this is around negative 1. And I don't really care about the values exactly, but this is a little bit less than 2, means this is about 1.9. This is where I get my teeny negative from. So I put this all together, a negative divided by a negative times a negative, all together is a negative divided by a positive, which is a big negative. So then I get that f at x goes to negative infinity overall. I should have been able to figure that out, right? I know that it was either going to go high here or low here, but there aren't any x-intercepts over there. So I should have known that this was going to go low here. What's funny here is I don't know what's going on inside here. I've got no x-intercepts, so I have to do the behavior as x goes close to 2 from the right. So again, let's do the same little analysis. I got my function there. I'm not going to recopy it. But x is close to 2, but a little bit more. Top's still negative, isn't it? The bottom here, this is still negative, because this is around 2, so this is still negative. But this one, since this is a little bit more than 2, I subtract 2. This is a teeny positive. This is negative divided by a negative, which is a big positive. And I think of f at x going towards positive infinity. So that means this graph is up here. Right? Now let's think about this. I know that the graph is either going to go up here or down here. Which one does it have to be? It has to be high. It has to be this way, doesn't it? Why? What's the logic there? Well, it can't go low, otherwise I would have had an x-intercept in there. So I know this is going to happen. I'm going to do the calculation anyway, but would you have to do this? No, use your brain and you'll know that it goes there. Of course, if we want to do the calculation because we'd like to practice or because we just want to make sure, I'm going to move this down here. Actually, I'm going to do this calculation that I just scribbled out over here so I have more room on my sketch. So x goes close to 3 but is a little bit lower. I think of the function as x minus 4 and the factored version. The textbook actually does this positives and negatives in a table. If you've looked at the textbook, it's kind of an interesting way to do that. When x is a little bit less than 3, this is a little bit less than 3, subtract 4 is still -1. This one, though, a little bit less than 3, like 2.9, a little bit less than 3, this is where I get my teeny negative from, teeny value. Now this one, though, notice 3 subtract 2, or just a little bit less than 3 subtract 2, that's a positive. So I get a negative divided by a negative is a big positive. And then I get f at x goes to positive infinity, just like we knew anyway because we used our brain. The next part here is interesting, as when on the other side of the horizontal asymptote or vertical asymptote, I don't know, right? I don't know what's going on here. So let's do the calculation. X goes to 3 from the right. I get f at x is 3 from the right, still a negative on the top. But on the bottom, this is a positive now, right? Just a little bit above 3, subtract 3 is a teeny positive. And this one is, well, this one's still positive. So I get a positive times a positive on the bottom. Negative divided by a positive is a big negative. So that means f at x goes to negative infinity. That means it's down here. And I probably could have guessed that, not because of anything else except for it just has that pattern. And now what happens? I know something strange happens here. It actually touches the horizontal asymptote, but I know it has to end close to the asymptote. So it actually comes back up here somehow and then starts going back down. And that's a strange thing, but it happens. And same in here. I don't know how far down this goes. Now this dotted part here, I'm going to circle it in a different color. We don't know this. We don't know that, or how far up does this go. Certainly we could try some values, 2.5 or 5 or 6, and try and figure out how far above this goes, but we don't know. The solid parts we're pretty sure of. These dotted parts circled in blue, we're kind of sad about that. We're not sure. It's a little bit confusing for us still. And in fact, we won't get much better than this until calculus. And if you don't take calculus, well, you're missing out, because we can't draw our rational functions exactly. All right, that's it for today. Hopefully you got through the investigation okay. There's only a few to do for homework, so you should be able to polish that up fairly quickly. That's it.